Hello. This is my third video on graphing rational expressions, and we're covering something very specific in this particular video. We're covering holes. So there might or might not be a hole. Not every graph even has one. I know in my class, unless I've taught you about holes, I've been giving you problems where there is not a hole in the graph. And a hole is just a point, a spot, a single point on the graph where the value of the function is not defined. It doesn't work. And in terms of what we're familiar with, it's a thing that canceled out. So we've definitely simplified rational expressions like this, okay? And that's what we need to do to find the hole. So I'm looking at this, and I'm going back to my good old factor the top and factor the bottom both as much as I possibly can. So on the top, I'll factor out an x. All right, there's the top factored apart. And on the bottom, I see difference of two squares. So when I factor that, I get x minus 4 and x plus 4. So notice that my x plus 4's cancel out. That means that term, x plus 4, well, that's where my hole is. That's where my hole is. So when that spot on the graph, that is a hole, the function doesn't work. So this means if I set that equal to 0 and I solve for x, what I get is x equals -4. So at x equals -4, if I find the spot that should be on my graph, it's not going to be there. It's going to be a hole. In terms of, can we see it on the graph? Let's see. Plug this in. Here we go. Let's see if I can get you good light. So see, I have the function in there. I'd hit enter and draw. And so there's the graph, and it looks fairly normal. But if I go to my my table of values, and here's my table of values, ready? And I'm just gonna type in -4. I'm gonna hit enter, and it says error. It doesn't work because that one little single tiny point on the graph, it doesn't work. It just stops there. There's a hole in the graph. It's exactly what it sounds like. So the great news is the process for finding a hole is something that we've totally already been doing. Let's try just one more. This is going to be shorter than the other videos. Okay. So in order to find the hole in this graph, I have to just simplify this expression. And if anything cancels out and goes away, that's going to be my hole in the graph. So let's factor the top. I can factor out a -4. So on the top, I have -4 times x plus 2. There's my top, my numerator factored. On the bottom, I have to actually factor the trinomial. So let's see, two numbers that add up to 5 but multiply to make 6. And I'm thinking 3 and 2. They'll both be positive. So I've got x plus 3, x plus 2 equals y. Well, there it is. I can see it. The x plus 2 cancels out, which means 0 equals x plus 2. That's where I'm going to find my hole. I do have to solve for x. So at x equals -2, I have a hole. If I graph it, then I just know that there's a little hole, a little gap in the graph at that point. And I might not always be able to see it. Let's see here. So let's go to graph, and we'll plug this in, okay? Well, here, let's just delete that whole thing. So for this graph, kind of get some of my buttons in there so you can see what I'm doing. So for this graph, I have -4x minus 8 on the top. I'll go down, and I'll put x squared plus 5x plus 6 on the bottom. hit enter and draw. And let's get a look at this, okay? So for my asymptotes, I have to figure that out. That's kind of old stuff at this point, right? So the bottom equals 0, or rather it can't equal 0, which means at x is -3 and -2, I have some asymptotes here. Well, the -2 is gone, really, so that's a hole. But at x equals -3, I have an asymptote. I can kind of see that in my graph over here at x equals -3. So let's put that in here. I didn't read my own directions and remember that I wanted to graph this. All right, now for our other asymptote, let's see. Our largest exponent up here and our largest exponent down here, the one on bottom is larger than the one on top, and it's looking like that means we've got a horizontal asymptote. That's gonna put that asymptote right on the axis. Let's see. It's kind of hard to see when I draw it right on the axis, but it's there, okay? And I can see from my picture that the graphs approach both of these axes but don't cross. Well, I need some points on my graph then. I have an idea what it looks like. I've identified the hole. Now, in my class, I want you to actually tell me what the asymptotes are. So my vertical is at x equals -3. My horizontal is at y equals 0. So on your homework, don't forget to actually identify those things. Let's check out other important points. I'm going to go over to table of values and get my table of value and just grab some points. I see 1, -1. Well, 1, -1. Let's go a little to the left. Let's go to -1. So I'll punch in -1 and I get -1, -2. So it's going down this way. And then here, I'll get -2. So I'll punch in -2 and I get -2. Oh, that's right. That's my hole in the graph. Well, let's try -2.5 when it's getting really close to the asymptote. It's -8. So at -2.5, it's all the way down here. So there's this side of my graph. Sometimes it looks almost pointy there, but it should be nice and curvy. And let's check it out over here. So let's try -4. -4, +4. So way over here, -4, +4. Okay, let's try -5. -5, +2. There we go. Let's try -6. How close is this getting? Let's try -7. I'm looking for a whole number. -7, +1. There we go. And really, 3 points, something like this is enough. And I've got a great example of my graph. I have identified the asymptotes. I sketched the graph. I identified the hole. I can write what that is. That's the hole. And that is it for now.